minus y by y square plus 1 dy. Integrate, now the variables are separated. So integrating on both sides. Integrating on both sides, we get integral of x by x square plus 1 dx is equal to minus integral of y by y square plus 1 dy. So you already know, multiply and divide by 2 so that it is in the form f dash x by fx, 1 by 2 into 2x by x square plus 1 dx is equal to minus 1 by 2 into integral of 2y by y square plus 1 dy. So this is integral of f dash x by fx is log fx. So log of x square plus 1 is equal to minus half into log of y square plus 1. Add the constant also as log c. Then it is easy to simplify. So it is half into log of x square plus 1 plus half into, I will take half common, log of y square plus 1 is equal to log c. Is equal to log c. This is in the form log a plus log b. Log a plus log b is log a. So that implies log of half into log of x square plus 1 into y square plus 1 is equal to log c. You take it to the power half. So it is log of, it implies log of x square plus 1 into y square plus 1 or take 2 to this side is equal to 2 log c. 2 log c can be written as log of c square. Now when you take anti-log on both sides, so you get x square plus 1 into y square plus 1 is equal to c square is the required solution. So this is the required solution of the given differential equation. So let us we do the problems. So in the last period I gave homework. You can just try those problems. It is just finding integration only almost. Once you separate, integration process may take time. That's all. Like suppose you have an equation like this, dy by dx is equal to. Suppose you have an equation, solve the differential equation, dy by dx is equal to sine of x plus y plus cos of x plus y.
Direct mother dear
Sine of x plus y plus cos of x plus y. Can you separate the variables here? Is it possible? No, because here you have y inside the cos and the sine. You cannot do. So what you do is use substitution. Put x plus y is equal to some t. Then differentiate with respect to x. You take this given equation as 1. So the question is again saying solve the differential equation. So given differential equation is this. Given differential equation is. So because it cannot be reduced to the variable separable form, put x plus y is equal to t. So differentiating with respect to x, it is d by dx of x plus d by dx of y is equal to d by dx of t. So d by dx of x is 1. So 1 plus dy by dx is equal to dt by dx. So that means dt by dx is equal to, dy by dx is equal to dt by dx minus 1. Now substituting in first equation, substituting in 1, we get, now the given differential equation becomes dt by dx minus 1 is equal to sin t plus cos t. Sin t plus cos t. So that means dt by dx is equal to 1 plus sin t plus cos t. Now as I said, we have t and x now, so you have dt is equal to dt by dx into dx. Instead of y you have a t here, so use the same form. So that means dt is equal to 1 plus sin t plus cos t, sin t plus cos t into dx. So this whole thing should come down here. So that means dt by 1 plus sin t plus cos t is equal to dx. Now integrating on both sides. Now you are integrating. Integrating on both sides we get. So integrating on both the sides we get integral of 1 by 1 plus sin t plus cos t dt is equal to integral of dx. Now how to integrate this? Actually, you have one particular method that is deleted this here. We'll try to solve it in terms of our known methods. We'll write 1 plus cos t plus sin t, and then we'll write 1 plus cos t as 1 plus cos t we'll write as 2 cos square t by 2, and then sin t as 2 sin t by 2, 2 sin t by 2 cos t by 2 dt. This dt I mean dt is equal to integral of dx. Now from this you take 2 cos square t by 2 common. 2 cos square t by 2 common. Then what is left here? 1 plus 1, 2 you have taken, cos t you have taken, sin t by 2 will be left out. And then you have taken cos square t by 2. No? So here you should write 1 cos t by 2. Cos t by 2. So if you multiply, you see, you learn this problem, learn this procedure. This is very important for 7 marks. So 2 cos square t by 2. Again, when you multiply, you are getting this. You can just check. Dt is equal to integral of dx. Now what you do is you write this as secant square. So you take 2 also to the numerator and write as half into secant square t by 2. 1 by cos square t by 2 is secant square t by 2. And write this as 1 plus tan t by 2. 1 plus tan t by 2 dt is equal to integral of dx. Now if you observe, this is in the form f dash x by fx. The derivative of 1 is 0. The derivative of tan t by 2 is secant square t by 2 into the derivative of t by 2. That is 1 by 2. So it is in the form of f dash x by fx. So it is log of 1 plus tan of t by 2 is equal to x plus. But what is our, because integral of f dash x by fx, integral of f dash x by fx is log of f of x, log of f of x, or t here. Here our function is t. So you are applying this formula. Okay. Now what is our t? Finally you should substitute the t value. Then only your answer is complete. Your solution is complete. So in place log of 1 plus tan of t. What is t? X plus y. X plus y by 2 is equal to x plus c is the required solution. So this is the required solution of the given differential equation. Given differential equation. So like this you have to do. Okay, now second problem. Solve the differential equation dy by dx is equal to x minus 2y plus 1 by 2x minus 4y. So if you observe here, you cannot separate the variables. X and y are there both in the numerator and denominator. But if you observe this part, x minus 2y, and here 2 into x minus 2. So you put x minus 2y as t. So the substitution is different in different problems. You yourself should identify what is repeated. It will be repeated in the, that expression will be repeated in the question. So put x minus 2y is equal to t. Now differentiating with respect to x. Differentiating with respect to x, d by dx of x minus 2 into d by dx of y is equal to dt by dx. So that means 1 minus 2 dy by dx is equal to dt by dx. We need dy by dx to substitute in the first equation. So what we do, we'll take this term to that side. 1 minus dt by dx is equal to 2 into dy by dx. So that means 1 minus dt by dx by 2 is equal to dy by dx. Now substituting in 1. So substituting in equation 1. Substituting in equation 1 we get, what is our equation? Dy by dx is equal to x minus 2y, I'll put in brackets so that I can write it as t, and 2 into x minus 2y. So x minus 2y you are taking as t, no? So the equation becomes dy by dx is nothing but 1 minus dt by dx by 2. dt by dx by 2 is equal to t minus 1 by t plus 1 by, this is t plus 1 by 2t. 2t. So 2 and 2 will get cancelled. So it is 1 minus dt by dx is equal to t plus 1 by 2. Now see how simple it is. Yeah? Take 1 to that side. So minus dt by dx is equal to t plus 1 by t minus 1. So it is t plus 1 minus t by t. So t and t will get cancelled. So that means minus dt by dx. So the problem has become very simple now. Now separate the variables. We have dt is equal to dt by dx into dx. So what is dt? What is dt by dx? Minus 1 by t. So minus 1 by t into dx. Take t to this side. So t dt is equal to minus dx. Now integrating on both sides. So integrating on both sides we get integral of t dt is equal to integral of minus dx. Integral of t dt is t square by 2 is equal to minus x plus c. But what is our t? T is x minus 2y. So that means x minus 2y whole square by 2 is equal to minus x plus c. So that means when you cross multiply it is x minus 2y whole square is equal to minus 2x plus 2c. 2c is again some c only, so you can write x minus 2y whole square plus 2x is equal to some constant 2c is the required solution of the given differential equation. So like this we do the problem. Yes, next problem. Solve the equation sin inverse of dy by dx is equal to x plus y. Sin inverse of dy by dx is equal to x plus 1. So here what you do is dy by, it is not in the standard formula, sin inverse is there. So take sin inverse to that side. Then it becomes, so dy by dx is equal to sin of x plus 1. Now can you separate the variables? No, it is not possible. So same thing, put x plus y is equal to, this is again very important, put x plus y is equal to t. So differentiating with respect to x. Differentiating with respect to x. Derivative of x is 1. 1 plus dy by dx is equal to dt by dx. So that means dy by dx is equal to dt by dx minus 1. Minus 1. Take this as equation 1. Now substituting in the first equation. So substituting in 1 we get dy by dx is what? dt by dx minus 1 is equal to sin t. Now take 1 to that. So that is dt by dx is equal to 1 plus sin t. Now we know that dt is equal to dt by dx into dx. Implies that dt is equal to, what is dt by dx? 1 plus sin t. So 1 plus sin t into dx. So this 1 plus sin t, whole thing should go down here. So that implies dt by 1 plus sin t is equal to dx. So we separated the variables. Integrating on both sides. Integrating on both sides we get integral of 1 by 1 plus sin t dt is equal to integral of dx. Now 1 by 1 plus sin t, how to integrate? Always remember, when you have 1 by 1 plus sin t or 1 by 1 plus 1 minus sin t or 1 plus cos t or 1 minus cos t in the denominator and numerator is 1. Then what you do is multiply and divide by the other term. The 1 plus sin t is there, no? So multiply and divide by 1 minus sin t. Multiply and divide by 1 minus sin t dt. Integral of dx. Then what happens? Always we can reduce it to the known form like this, 1 minus sin t. So this is 1 plus sin t into 1 minus sin t is 1 minus sin square t. 1 minus sin square t is cos square t. So 1 minus sin t by cos square t. Cos square t dt is equal to integral of dx. So dt. Now divide separately. So it is 1 by cos square t minus sin t by cos square t dt is equal to integral of dx. Now 1 by cos square t is secant square t. So secant square t minus sin t by cos t is tan t into another 1 by cos t becomes secant t. Secant t dt is equal to integral of dx. Integral of dx. Now this you all know the integrals of these two. These are the standard formula. Integral of secant square t. Integral of secant square t is tan t minus integral of tan t secant t is secant t is equal to x plus c. Constant of integration you should add on any one side. Okay. So this implies now you have integrated. Now substitute that t. What is it? So tan of x plus y minus secant of x plus y is equal to x plus c is the required solution. So this is the solution of the required of the given differential equation. So like this we do the problem. Okay, now always remember when you have 1 plus sin t or 1 minus sin t or 1 plus cos t, 1 plus cos t or 1 minus cos t here. Multiply and divide by the other term and then you can always reduce it to the standard form. Okay, next problem. Solve the differential equation dy by dx plus y square plus y plus 1 by x square plus x plus 1 is equal to 0. So again here you can separate the variables. So dy by dx is equal to minus of y square plus y plus 1 by x square plus x plus 1. Now it is dy is equal to dy is equal to dy by dx into dx. So it will not come under variable separable. It will be under variable separable form. We need not use any substitution. So dy is equal to minus of y square plus y plus 1 by x square plus x plus 1 into dx. So that means dy by y square plus y plus 1 is equal to minus dx by x square plus x plus 1. Now integrating on both sides. Integrating on both sides we get integral of 1 by y square plus y plus 1 dy is equal to minus integral of x square plus x plus 1 dx. So once you integrate one side, the other side you can write in the same way. So how to integrate? So you reduce it to the standard form. Y square plus 2 into y into 1 by 2. So add and subtract 1 by 2 whole square. 1 by 2 whole square. And then plus 1. So I will write the dy, left hand side. Left hand side is equal to integral of 1 by y square plus y plus 1 dy. So that we will write in the standard form. Then same way we can write the integral on the left side also, right side also. So it is 1 by y plus half whole square, y plus half whole square, and this is plus half whole square and this is minus half whole square. So minus 1 by 4 plus 1 dy. That is root 3 by 4. So y plus half whole square minus root 3 by 2. 3 by 4 you will write as root 3 by 2 whole square. Root 3 by 2 whole square. Yes. So that is integral of now this is in the form 1 by x square minus a square. So 1 by 2a. 1 by 2a log of x minus a by x plus a. X minus a by x plus a. X plus a. This is the formula. So 2 and 2 will get cancelled. So it is 1 by root 3 into log of 2y plus 1 minus root 3 by 2y plus 1 plus root. So this is the integral. Sorry, this is plus. This is plus root 3 by 2. Oh. So now it is not logarithm formula. So it is tan inverse. It is in the form 1 by a square, x square plus a square. So 1 by a tan inverse x by a. 1 by a tan inverse x by a, root 3 by 2. So this is 2 by root 3 into tan inverse of 2y plus 1 by root 3. So this is your answer. So similarly, right side is also equal to 2 by root 3 into tan inverse of, instead of y you write x, 2x plus 1 by root 3. So substituting in 1 we get the required solution as substituting in 1 we get the required solution as so when you substitute, left side is 2 by root 3 into tan inverse of 2y plus 1 by root 3 is equal to minus 2 by root 3 into tan inverse of 2x plus 1 by root 3 plus c. Or you can take this term to this side and then you can take 2 by root 3 common and then take it to the constant also. So you can write 2 by root 3 into tan inverse of 2y plus, you can leave your answer like this, even this is correct. You can write your answer like this. Because 2 by root 3 is same, you can also simplify like this. Plus tan inverse of 2x plus 1 by root 3 is equal to c. Anyhow 2 by root 3 is a constant. That also when you take to this side it becomes again another constant. So I can write this whole thing now in the form is equal to 2 root 3 by 2 c. Or another c. It is already a constant. So you can write as another c and write the answer. So like this you can do. Now you can take down the homework. Solve the differential equation. Dy by dx is equal to tan square of x plus y. So this is the equation reducible to variable separable form. Put x plus y is equal to t like that. So answer is x minus y minus half into sine of 2 into x plus y is equal to c. First problem, next second one. X minus y whole square. Solve the differential equations. X minus y whole square dy by dx is equal to a square. So the answer is y is equal to a by 2 into log of x minus y minus a by x minus y plus a. Next step. Dy by dx is equal to root of y minus x. So the answer is 2 into root of y minus x plus 2 into log of root of y minus x minus 1 is equal to x plus c. You do one thing, here we put y minus x as t square. Put y minus x as t square and solve, then you can easily integrate the equation. Okay, next problem. Dy by dx plus 1 is equal to e to the power x plus y. Here also you write answer is e to the power minus of x plus y plus x plus c is equal to 0. The next problem. Dy by dx is equal to 3x plus y plus 4 whole square So the answer for this problem is 1 by root 3 into tan inverse of 3x plus y plus 4 by another problem. Last one, dy by dx minus x tan of y minus x is equal to 1. So for this, the answer is log of mod sin y minus x is equal to x square by 2 plus c. These are the problems. We completed almost all the problems. You can try these problems. Here you can put y minus x as t square. In this problem, I put y minus x as t square differentiation. Thank you.
ఆ చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు అదే డిజిటల్ భరోసా.
Hi students, this is Ramohan, JLN3, Government Junior College, Kachiguda. Today, our topic, Shatavana's administration. In previous class, we completed the political history of Shatavahanas